5.3 is going to continue in this section talking about synthetic division, which is really a shortcut because long division that we were just doing in part 1 can get pretty cumbersome and pretty long. Now, a couple of things. We can only use this if our coefficient equals 1. It gets kind of tricky when your coefficient isn't 1, so we're going to only do coefficients of 1. In the formula, it talks about x minus r, with this r number being the one that we're interested in. So if you notice that this is a minus, that's going to play into what our number looks like versus x plus r, okay, in our divisor. And I'll talk about that in a minute. The other thing I want to bring your attention to and think about is placeholders. So remember in old-fashioned elementary school division, you would sometimes have to put in a 0 to place hold as you were moving your numbers across. When we do this, we always have to make sure that all of our terms are represented, our degrees in descending order. So I need a cubed term, a squared term, an x term, and a constant. And if any of those are missing, you need to insert a 0 placeholder. So here's how this goes. Here's my divisor, and it looks like x minus r. And so I'm going to pull that 2 out, and I'm going to do a little bracket like that. That's what's going to go into the other numbers. Then what I'm going to look for and I'm going to pull out is just the coefficients in each one of the terms that I'm dividing into. So the coefficient of the x cubed is 1. The coefficient on the x squared is minus 4. Coefficient on the x is 6. And the constant is minus 4. And then you draw a line. Here's where this gets fast. Bring down the very first term. Then I'm going to say 2 times 1 is 2. Add them together, negative 2. 2 times negative 2 is negative 4. Add them together. 2 times 2 is 4. Add them together. What do you have here? This is your remainder. Work backwards. This is your constant. Here is your x term, your linear term. Here is your x squared term. So what my answer is, and then these numbers all represent the coefficients. So I have 1 times x squared minus 2x plus 2. And that's your answer. So once you kind of get the hang of synthetic division, you can see how fast it really goes. So let's try another example. So here's my divisor. So again, it's x minus r, so I'm going to pull out that 2. If, for example, I was going to divide by x plus 3, notice this is positive, so I'd really need to think x minus r, so I would put negative 3 in the box, and then my other numbers here. I always kind of want to do the opposite when you're pulling out that number. So what are my coefficients? 5, negative 13, cubed, squared, x is 10, my constant is 8. So I have 5, negative 13, 10, negative 8. Draw your line. First term comes down. 2 times 5 is 10. Add negative 3. 2 times negative 3, negative 6. Add is 4. 2 times 4 is 8. Add, you get 0. So what do I have? If this is my remainder, this is my constant, here's my x, here's my x squared. I have 5x squared minus 3x plus 4 as my answer. Now, if my divisor is something other than a lead coefficient of 1, it is easiest to use long division. because it's kind of tricky to use synthetic division with something other than 1. You'd have to divide it out and actually use a fraction. And we know that we don't love fractions that much. So I'm going to go ahead and do long division. So I'm going to have 2x plus 1. And how does that go into? Now look what happens. I have a fourth term, a squared term, a constant term, but I am missing an x cubed term. So I actually need to insert that in as a kind of placeholder. But I don't want to change the value of my fraction or of my expression here. And so what I do is I multiply it times 0. So there's really no value there, but it is holding my place for me. So I'm going to go through and I'm going to say, how many times does 2x go into 8x to the fourth? Well, it goes in 4x cubed. So it goes over that x cubed position. Now I'm going to multiply. 4x cubed times 2x is 8x to the fourth plus 4x cubed. How many times does, subtract. So I have negative 4x cubed, bring down the next term. How many times does 2x go into negative 4x cubed? It goes in minus 2x squared. Multiply 2x squared times 2x gives you minus 4x cubed. Negative 2x squared times 1 is minus 2x squared. Remember when I subtract, really doing the opposite signs. So I have negative 2x squared. Bring down the next term, plus x. How many times does 2x go into negative 2x squared? It goes in negative x times. When I do that multiplication, and then I'm going to subtract, which means switch the sign. So I have 2x, bring down the last term. How many times does 2x go into 2x plus 4? It goes in 1 time. And so I have 2x plus 2. But remember, subtract. And so I have 2 as my remainder plus 2 over 2x plus 1. So my whole answer when I'm all done is 4x cubed minus 2x squared minus x plus 1 plus 2 over 2x plus 1. And that is your answer. Again, longer, but really makes it much easier than synthetic division. So we have one more example here to run through. Another long division example. Slide it down out of my writing. And we'll get going. So again, how many times does 2y minus 1 go into this long thing? Again, I check my terms. I have y to the fourth, y squared. Oh, I'm missing y cubed. So I need that placeholder when I go in. So I'm going to have 2y minus 1 goes into 4y to the fourth plus 0y cubed minus 5y squared plus 2y plus 4. And we just repeat the process. So how many times does 2y go into 4y to the fourth? It goes in 2y cubed. Then I do my multiplication, 4y to the fourth. 2y cubed times minus 1 is minus 2y cubed. But when I subtract, my signs switch. And so I have 2y cubed minus 5y squared. Bring down the next term. 2y goes into 2y cubed, y squared times. Do the multiplication. I end up with 2y cubed. Negative y times positive y squared is negative y squared. Do your subtraction by switching your signs. And I end up with negative 4y squared. Bring down your next term. It's very important to write clearly and neatly so that you bring everything down. One trick is to turn your paper horizontally so the lines are going vertical instead of horizontal and use each one of those as a column to put your terms in, so you line everything up. 2y goes into negative 4y squared, negative 2y times. Notice how my 2y is over my y terms over my y squared's over my y squared. Do my subtraction. Negative 1 times negative 2y is positive 2y. Subtract. I end up with 0. Bring down the next term is 4. 2y doesn't go into 4, so there's actually no constant term. And then my remainder is this. So my answer is 2y cubed plus y squared minus 2y plus 4 over 2y minus 1. And in this case, there doesn't happen to be a constant term. So that is your lesson for 5.3. Good luck with your homework.